All right. So today we're going to talk about now that we've built an AI model, soup to nuts, we've gone from like day one of just talking about what is a learning model to processing data with PyTorch, from building a binary classification model to optimizing it to finally creating a multi-classification model for student grades like we did yesterday. We're going to see how to use it in a simple application. And for today, the application is going to be a simple command line program to get student information and then use our model that we've trained to give us a guess on what the student's grade in a class, in some upcoming class, is going to be. Um, to get there, we're going to see one way to export a learning model that we've trained, how to import it. We're going to migrate our code out of Jupyter Notebooks and into normal Python code, and then we'll see what like a simple sort of program design for using that for a command line program, probably in an object-oriented fashion if we have time, looks like. Also, I would love maybe towards the end of this morning, Jack, if you're willing, or if anyone who worked on that like stellar classification model wants to just like basically do a code demo on it and talk about what they had to do and the challenges that they encountered. I think that'd be really cool to see as sort of like a real world scenario. Do folks have any questions about the plan for this morning? Okay, cool. So first off, I am going to make sure, since I just copied over a whole bunch of Jupyter Notebook files and other code, that everything is working here. So I am going to select my environment. We'll give the Jupyter Notebook a moment to search for it. Um, and then when it's done, I am going to click and make sure that everything's looking good. But let's see. Oh, it's going to take a minute. Well, while it's doing that, let's start talking about moving our code out of Jupyter Notebooks and into separate files. And I think we'll actually talk about this first because we can migrate this code and then we can run it to build a model and then we can talk about exporting and importing. So this is the process called refactoring. And refactoring is when we don't change what the code does, but how it does it, right? We're not going to change our model's weights or biases. We're not going to change, or rather, we're not going to change the number of neurons in each layer. We're not going to change, the activation layers or anything like that. And just to kind of recap and take a look at our model, we're not going to change all this data normalization code that's here. Um, if we change any of this, it will be because it's a necessary step in the migration. Um, and then, and now it looks like the Jupyter Notebook did find the environment, which is good. And we're not going to change this model, our multi-classification model. We're not going to change our training logic. And we're not going to change our evaluation logic, right? But we are going to move it all out of Jupyter Notebook and into individual Python files. And let me go ahead and make a directory for this. I'm just going to call it student app. And we'll put all of our code in here and sort of organize it as we go.
Adam, I have a question.
Yeah.
Um, so when you're starting a project, I know in a lot of larger projects that file structure is typically pretty important. When you're starting a project, is it best to go ahead and like establish that file structure like right off the bat before you actually start getting into it, knowing that you're gonna kind of expand, or is it really just like up to coder preferences? Like I know that I personally like to set up my file structure as it would be in a finished project, but is it typically industry standard to just sit there and do that, or does that usually happen during the refactoring phase?
Yeah, that's a great question, right? Basically, should I start making my directories now so I have something like, learning model.py and and another file, and maybe this is the data preprocessing.py, and then we might have another file, let's say like train model.py. We might have evaluate model.py, and we might have the actual um, student app itself, and we might have our main method. Um, and we might, depending on how we write our code, we might even have like a terminal UI class. I'm going to delete some of these directories as we get into it, but you raise a really good point, Max. The short answer is yes, but when we learn Django, Django has a very specific project structure. We have to put certain files in certain directories, and there absolutely are conventions and standards. So Django won't break if we don't follow them, but it's how every other Django programmer does it for how we organize our code with files and things like that. In general, it's a really good idea to set up your project structure early. However, frankly, especially learning this stuff, you all don't have the experience yet to have like used a bunch of different project structures and kind of have conventions. Um, so I think the short answer is whatever helps you move forward. Um, like we can in fact do a little TL draw diagramming to figure out what our application is going to look like. And I would say this is the really important part is doing some upfront design. It doesn't necessarily have to be um, drawing boxes on TL draw. Um, and if making files helps, then I would say go for it. Um, so the answer is really it depends because if you're working on a certain with a certain framework like Django, it's going to want you to do it a certain way. If you're doing your own application, it really depends. What I do, and this is more specific to refactoring, what I really like to prioritize is I don't like my code to be in a bad state. So, like my workflow for this refactoring process is going to look something like this. Put all the Jupyter code into one big file, run it, make sure it works. And this means, data pre-processing, building the model, training the model, evaluating the model. Once it is working outside of a Jupyter notebook, then think about how I want to organize the code in different files, etc.
Is it
And
best to,
really, to do this, I would
sorry.
probably be thinking about like how do I want to design my whole program? What classes will I create? What functions, etc. Um, it is good practice to do some upfront design. And I would encourage you all to get in the habit of it, even if it's a couple lines of pseudocode or like we'll say TL draw today. Um, I think starting out, this workflow can be harder for folks because you kind of have to know where you're going to end up. And a lot of people do like setting up the structure first. The one thing I will say about this approach is this workflow kind of minimizes the chance of bugs and user error, right? Because we've got a lot of code to move. We've got 5 different cells. They import stuff. They depend on stuff from other cells. It's really easy just to have a bug creep in just because I forgot, maybe something needs to be made here. Like something here needs to be used here, or there's just ways that mistakes can happen. And so if I go straight from putting all of these into its own separate files, for me at least, that increases the chance that I'll make a mistake. But if I stick it all in one, yes, I may make a mistake, but it will be easier to fix and debug. And then when I have it working outside of the Jupyter notebook, I can better organize it. So I it's a difficult workflow to learn. This kind of was drilled into me over years in the workplace, but I do think there's value into like seeing how can I break work up into small steps where each step is easier. So that was a very long answer, but did that help address your question, son? Yeah. The short answer is if you want to make files, make files. If you don't, don't. But at some point, you should be doing some planning of how your program is going to be organized. And, I think if you want to think about files as like an analogy for classes or functions, that's fine. But really, it's thinking about program design, like what classes, what functions, how does my data get passed around? And we're going to see that in a little bit. Um, and I would say there absolutely is an industry standard in that as software engineers, really, it's like the program design piece that we're hired for, and that gets evaluated in technical interviews and stuff like that. Everyone has a different way that they like organizing stuff. So, the details of how you kind of do your design is less important. Um, but I think it's important to practice that step. And the last thing I want to mention is all this that I'm talking about. I don't know if it sounds relevant or not, or overkill or not, but um, like raise your hand if you introduce a bug into your code for OOP or from week 1 of class that was from a programmer error, right? Essentially like a typo or any sort of programmer error. And keep your hand up if you spent more than 30 minutes trying to debug it. And that should be literally everyone, right? My guess is we're talking hours, not like minutes, right? So what this process really is when we're writing code 5 hours a day, I don't want to increase the risk of programmer error. I want to minimize the risk of programmer error. I don't want to, introduce those bugs. And the secret to that is workflow. Um, I am very passionate about it. I do think it just comes with practice. Max, I hope that was helpful. I realized there was a little hand waving there. Um, but I also think, some of this just comes down to everyone thinks about stuff a bit differently. Some people like to dive into code. Some people like to do a lot of upfront design. At the end of the day, you need a bit of both, but it's really up to you to a degree how you do it. But the important thing is be able to have a plan and to communicate to someone else what that is. right? Because if you don't have that, then we're not really software engineers. We're sort of like hobby coders. Like a software engineer is someone who can explain the program, how it's designed, how it works, and communicate that information to someone else. That's really our job at the end of the day. And
Yeah.
who, like, when a business person comes to them with a list of things that they want, come up with a design and tell the business person, hey, that feature is great. We can do that. That one, it'll take 3 months of work. Do you really want it? We might be able to do it this way that's slightly different. That would only take like 1.5 months. Would that work for you as well? Right. That's really the skill that we're learning here. Um,
Yeah, typically I will just start out with writing everything, like keeping everything simple, single responsibility and segregating everything into its own files and stuff. But what I have trouble with is moduling and namespaces and referencing each other from other files, like especially if some of my code happens to be in an init file.
yeah. I mean, and that makes sense. I think it sounds like you are practicing good principles. Um, and the reality is, like, it's very difficult to talk about this stuff in the abstract. We can, but it's actually not that useful. It's sort of like, I don't know, critiquing a painting that doesn't exist.
Right,
What's much more useful is like code review and discussion. Um, the construction metaphor is used for writing software a lot, right? And like, yes, there are design principles, and like as like builders or architects, we can talk about abstract design principles. But the way you learn to build stuff is you look at real buildings and you talk about how they were designed and how they were built. Um, and it's the same with software. Also, the reality is simply that until our programs get big enough, a lot of this stuff just doesn't matter. It's good to practice it, but it really only starts to matter when our programs get bigger. And like for the first 2 weeks of the class, really only I would say the OOP assessment is maybe a big enough program where some of these design principles start to like impact like overall code quality and stuff. So they are good to practice, and they are good, important to be thinking about. I just don't want folks to get lost in the sauce on them. And by
or
far, the best way to improve on it will be through code review and discussion, or sending me code. I can look at code on GitHub till the cows come home and give people feedback. Um, yeah, yeah, great question. And I know I went off on a bit of a tear there because I do feel very passionately about it, and it's a bit more abstract. Um, let's kind of circle back to the task at hand, though.
thank you,
Um,
Adam.
yeah, great question, Max. And if folks are curious about stuff or have follow-up questions, I'd love to dive into them now. I just know that because I'm passionate about this topic, I can go on for a while. Okay, cool. And we are going to do some program design today and talk about this stuff. Um, but we're going to start by just putting all of the code into one big file. Because like I said, what I've learned from like a decade of experience is that your code is in one of three states. It's either, you know, good, bad, or I don't know. And out of the three, I don't know is the worst possible condition for your code to be in. Good code means it runs, it doesn't throw errors, and it does what it's supposed to. Bad code means it doesn't run, it throws an error, or it doesn't do what it's supposed to. But bad code is good because I get error messages, I get data, I can see how the program behaves, and I can fix it. If I, written 500 lines of code and spent 6 hours on it, I haven't run it once, I actually have no idea about the state of my code, right? So I think the goal is really keep the code base in a good state as much as possible, which means doing work in small chunks and running it as you go. And in that vein, let me just go ahead and do some refactoring now and kind of show this process in motion. Can everyone see this font size okay here, by the way? Okay, awesome. So I'm going to do a split. And once this is done, we will discuss the export process from PyTorch is actually pretty straightforward for the approach that we're going to use. That's going to be pretty quick. Um, and then we will do some program design. I just want to do this sort of refactoring migration first. And as to your point, Max, it is good to think about like what setup do I need to do? Like anyone know the term like mise en place from like cooking and chefs? So let's see here. There's undoubtedly a much nicer article on it, but it's a French culinary term which means putting in place or gather. It refers to the setup before cooking and is used in professional kitchens to refer to organizing and arranging ingredients, cuts of meat, relishes, sausage, blah, 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 that a cook will require that are expected to be paired during their shift. So, right, simple principle. If you're in a professional kitchen, though, it takes more work. And I really think as professional software developers, it pays to do a mise en place, like set up your code base. Like if I'm doing an assessment, I'm going to clone down the code. I'm going to set up a virtual environment. I'm going to make sure tests run. Because once I start writing code and doing work, I don't want that stuff to be a problem that takes me out of the flow and like out of my zone. So in that sense, like that's another reason why doing the migration first before the design sort of makes sense because we want to get everything set up and then we can think about it and design it.
I have a
So
question.
yeah, go for it.
It may just be totally off topic, but I guess like when you're working, for lack of better terms, and they give you like, hey, we want you to build this, do they give you like the rubric of that through testing, I guess? Like, do they just set up the test and say, hey, this is pretty much what we want, go build it? Is that how that works?
That is a great question. The answer is it totally depends. As a junior software engineer at a big company, so as a junior software engineer, pretty much anywhere, like your first month is going to basically be like this. You'll join, like once you start work and get through whatever the sort of company orientation stuff is, you'll have your work laptop. The team lead might say, okay, cool, here's like the README for the code base you'll be working on. It has install instructions. Just focus today on like getting your environment set up. And you might need to sign up for something, one of these password control, so password manager softwares, that the company's using and set up your account there and grab API keys from it. And you might go through a README with a whole bunch of install steps, and you need to get a whole bunch of API keys, and you're installing a whole bunch of dependencies. And they have you do this because they want you to start learning how to set stuff up, and also for your own growth and development as a software engineer. And then inevitably, the README will be missing something, and you'll spend an hour on it, and you'll go to your manager and say, I spent an hour on this. I can't figure it out. And your boss will say, oh, yeah, we changed that a month ago and we haven't had a chance to update the README yet. Here's how you do it. And I'm speaking from experience here. Um, and that's your first day. And then, by the way, what you should also do is offer to update the README. Companies like to have new hires do this because the new hires also, they spot all the pain points that the people who have been there for years got used to. And so offering to like update documentation is really value added as a new team member. And then your first task might be something really simple, but the code base is really complex. There's an automated test suite. It takes a bunch of steps to deploy. And so doing something really simple will take a lot of effort in the beginning because you've got to read through all this code. Because I'm not just writing a function to display the username on the website from scratch. There's already CSS code. There's already all this other code. And I have to like fit into the existing pattern. You know what I mean? You all have seen, raise your hand if you've seen a house with an addition that looks like, it was just a total hodgepodge, or like a house with a bunch of additions where like nothing matches and nothing looks right and nothing makes sense. Code bases can absolutely get like that as well. I'm sure you could imagine working on someone's code and doing stuff totally differently. And if you have a team of even 6 or 7 people, that's a real risk. If you have an engineering department of multiple teams where it's like, I don't know, a couple hundred people divided into teams of 10, and you have a couple shared code bases there. I mean, even a team of 10, and you figure a software engineer's turnover, before this job market, 2 years was not uncommon. Like early career engineers job shift a lot, and that's kind of how you grow. So it's really important to maintain consistency so we don't end up with that hodgepodge of a house. So there's all this sort of like learning the house coding style. Um, and point being, even for the simple stuff, when you're learning, that team's way of doing it, it takes more time, and I can't just do it the way that I want to. Um, but they give you these little assignments because they want you to learn the code base. And they want you to reach out and ask the guy who's assigned to you as a mentor for advice and how things work. Because as a junior engineer, that's like your first month or two. And then you will start getting tasks. And depending on the company, you might get a spec that's not unlike our READMEs that you've seen for assignments. Though ours, we try to be tricky on purpose. In the real world, it's tricky just because the product manager forgot to mention something and there's just a gap in there that people missed, and then you have to go ask someone to figure it out. Um, and depending on the company, that spec, that ticket, that Jira story, whatever form it takes, may or may not be well defined. It might be really specific, like ours are, or it might be vague and just say like display the user's birthday on their profile page. And then you kind of have to fill in the pieces there and figure that out. Um, but
I
really,
like
what
that.
companies want is for junior engineers to grow into mid-level engineers, and the goal there is where, like, as a product manager, I can come up to you and say, I would really like users to be able to like list their favorite foods, and then like maybe vote on what the best food is out of all the users' foods. And as a mid-level engineer, more or less, I think the expectation is that you can talk to that product manager, take those requirements from them, and turn that into some sort of like specification of, all right, we'll need a new page on the front end. I might need to write a new API endpoint. I'm going to need to add a new table to the database for favorite foods. Um, how much of that is mid-level engineer and how much of that is senior engineer varies, but that's pretty normal. And that's really how we add value as software engineers. All right, because as a junior engineer, not being able to do that means someone else has to do all of that work. And that's really the hard work in a lot of ways. So starting out, again, you're not expected to do that right off the bat, but that's very much the goal of where you should be going. Um, Different companies do this mentorship and learning process in different ways. Some are more structured than others. And that's why I can't give a straight up and down answer to like, as an early career software engineer, like how I kind of get work assigned to me, because it's going to vary. But in the big picture, in terms of like career and what we all should be aiming for, I think it's this. There's two really good definitions of a senior software engineer. And this is like a 3 to 5 year journey. One is me as a business guy, I can walk up to the fence, I can take a big ball of complexity and unknowns, throw it over the fence, hand it to the senior engineer, and walk away and trust that they will be able to handle it and they will come to me with any questions so that I don't have to think about it at all. Because I know that if there's something that they need to know, they'll come out to me, right? Senior engineers are really project managers and leaders. Another good definition of a senior engineer is if we all, were entrepreneurs and we all had $100,000 for an awesome business idea and we had one person to hire, and like until we start getting, a, 1,000 users, enough to convince some venture capital company to give us a little more money, that 100 grand is all we have. And bear in mind that a senior engineer's salary is going to be probably 100 to like 180, depending on the job market and what they do. So we can hire one person for 1 year. Who do we hire that we're trusting the future of this business to? Um, Frankly, I still struggle at that definition of a senior engineer. That's very much a startup specific one. At bigger companies, mentorship and development of junior engineers plays a hugely important role. But I think that definition does capture something important, which is like, if there's no one else to ask, can I figure stuff out and make a reasonable decision and be productive? Um, so again, this is not an overnight journey. This is a journey of several years, but I think it's really helpful to have that destination in mind, right? As we're learning and growing and doing stuff. Because otherwise, I think it becomes easy to get stuck. Again, thank you folks for being patient with me because I went down a huge rabbit hole there. Was that helpful? Interesting? Cool. Yeah. And Jack, great question. These are all great questions. Honestly, today's a shorter lecture, so it's a great time to ask it as well. Um, and I just want to say again, this is not an overnight process, so please don't stress out about all this stuff that I'm saying. Um, but really, the takeaway is what we're really learning to do here is how to learn skills, apply them, like plan things, organize, prioritize, and be able to get stuff done, as well as all of this technical knowledge, and to be able to collaborate and communicate with other people about it. Because especially with AI, right? Like those soft engineering skills are really where we bring value. And that's really what companies hire software engineers for at the end of the day. Um, yeah. What other questions do folks have? As long as we're talking about this sort of more bigger picture career stuff. What else might be people what else might people be curious about, or what else is on your minds?
Not really a question per se, but I would like to add, Adam, that when I got my first gig as a engineer, I was working for Jewelry Television.
Mhm.
You were right about the fact that they do assign you like little things to kind of introduce you to their code base, but
Mhm.
in reality, like the first month and a half, they had me just setting up my development environment. That's it.
Yeah. Yeah, totally. Oh, sorry, go ahead, Max.
That's it.
Yeah, no, I agree with you. And folks, like most of my career has been at small orgs or startups. Think like 200 people, but that had a product out there with users. And the startups were challenging for me and also great. But as a mid-level engineer, my timeline was basically like 30 to 60 days onboarding, like 90 days, you're expected to be a productive member of the team. And I definitely remember at one job, like I joined, my manager went on paternity leave, but I had this really awesome senior engineer as my mentor. And I was doing all the learning tasks for the first 60 days. And then for my first one-on-one with my manager when he came back, like literally the first words out of his mouth were like, well, you're not quite where we expected you to be. And I was like, okay. Um, that's also why startups don't hire junior engineers in general, because they kind of need people who can ramp up. Big companies do move at a gentler pace and there is more support, but tech, it's definitely a world where at the end of the day, there's an expectation of being able to figure stuff out. That said, the hardest thing I think is to realize that we're not supposed to figure it all out on our own. That like asking people is an important part of the process, and it is a tricky balance. And here at Code Platoon, the answer is ask, and we'll tell you. Like I'll tell you like if I think you should like spend a little more time on this before we look at it together. Um, and as to your point, Max, like a lot of open source projects will on their GitHub repos where they have stuff label things as like good first issue. Let's see if we can like find something that's not totally nuts here.
I
So
had to
here's
just
some sort of, I don't know, a rhythm game. And if we go and we look at, and actually this is a good thing to show too, as to your point, Jack. Actually, if we look at an open pull request, um, we can in fact see it looks like this is a bug fix. It's either a bug fix or a minor feature improvement, something about mouse wheel and scrolling. And you can see here that the person listed is going to either be the issue or the bug number. And indeed, it's a bug. There's a bug description, a breakdown of it. And in sharing their solution, they shared a video, which is not uncommon for front end stuff. It looks like that one is just sitting there, which is kind of sad. If we look at, let's see if there's a closed feature. Here's a good one. Add support for team chat channels. So unfortunately, they don't link to like an issue, but here you can see like how on this open source project, people are like sharing and communicating about the work they did. And in fact, they do link to like specific GitHub commits for like key bits of work that they did so that the people reviewing and looking at this code can easily go to the most important part because there's so much code in this project that, you know, if you weren't working on this, it could be hard to find. So if you look at how much code is here, there's all these config files. And this is, you know, I don't even know what framework they're using here. So don't worry about this being a ton of stuff. But you can see like there's an awful lot of code here. But if we go to issues with any luck, and of course there's none open at the moment, but good open source projects will try to add like good first issues. And this is a great example. Like there's a typo, but you know, look at how much code there is that we have to navigate through just to figure out where that typo is, right? And so the purpose of this isn't really fixing the typo. It's I'm new to this project. It took me like 4 hours to figure out what line of code I had to go to change, and I learned a ton along the way. And so tasks like that, sort of like learning tasks, are one of the classic ways that like junior engineers get skilled up, or even mid-level engineers, or senior engineers for that matter, on a new code base. Okay, it's a lot of talking. We should definitely get back to the refactoring. Do we want to take a short break or keep rolling for like another 10, 15 minutes?
I'm kind of cool to keep going.
All right, let's do it. So these are the 3 states of our code: good, bad, I don't know. I'm going to do a split. I'm going to get rid of that sidebar so we don't need it. I'm really particular about how I kind of organize my splits. And since we're moving the code from one to another, I want the Jupyter Notebook here on the left and this here on the right. And I'm just going to make a comment here, and we're just going to say, you know, all the learning model code. And let's just go through this step by step. And it's going to be simple because I'm going to do this in small chunks. But that's the goal, right? Is to take something that is a pain and make it simple. And, you know, and let me go ahead and select the Python interpreter. So I think that's why we're getting all of our squigglies. And now they're gone. So this is all of our data pre-processing code. So let's grab that. And I'm going to comment it now so that it's easy for me to find it later when I do want to break it into separate files. And we'll just copy this whole thing and paste it. But what does all of this data pre-processing code depend on? This is a bit of a trick question.
Is it the
On the
data that
import.
you're importing?
Yeah, it depends on the CSV file, right? So as a part of my migration, I'm going to take a moment to think about where I want that CSV file to live. Because I'm inside, I made a student app directory. I haven't moved any data in there. And so what I think I'm going to do is I'm going to make a directory named data, and I'm going to copy the student data, the student performance.csv into my data directory. And now, right here, I think I'm just going to do like data file path equals, we'll do data dir equals data, and I'll do an f string, and it's going to look like this. It's going to be data directory slash student performance CSV, and we'll call this student performance file path. And there's undoubtedly better ways to do this, but this is reasonable. And later on, if I want to get fancier, I have some building blocks. And of course, I'm now going to run this code and make sure I have some sort of print statement to make sure that it works. And in fact, I might as well just print here. Let's just print the testing loader just for good measure. So I've got a print statement here, print statement here. If I see those print statements, I know my data has been imported and that none of this other code threw an error. And so that's what I am testing now by running this code. And indeed, it looks like I have an error. No such file or directory /student performance.csv. This is the best kind of error. I did all that great work, and then I forgot to use my new file path. And now we're good to go, right? And maybe I bundle this up into a function later, but you know, small errors I love. And by doing it this way, we can keep our errors small. So we've done our data pre-processing. It seems to have worked just fine. So I'm going to comment out those print statements. And, you know, as to your point earlier, Max, I think something that's really important to think about is people use the construction metaphor for software a lot. And so there's like a design phase, and then there's an implementation or building phase. And then there can also be a testing phase. But the reality is that these are actually sort of a loop, because a lot of the times it's only after I do some implementing that I realize like what the best design to solve my problem is. So that's where all of these sayings come from. Like premature optimization is the root of all evil isn't because optimizing is bad. It's because we don't want to do it prematurely. And my other favorite saying, Yagni, you ain't gonna need it, also comes from this. It's not that good design isn't important and having good structure and like lots of things organized well in files and classes isn't important. But if we kind of wait till we need it, then we actually have a really good understanding of what it is we actually need, like for this real program in front of our face and not in sort of an abstract sense. Also, as you can see, doing it this way just helps reduce programmer error, which is really our biggest enemy. So I've got all of my pre-processing code. Now let's go ahead. Let's build our model. And I'm just going to grab this import statement and stick it up at the top here because I do want all my imports in one spot and I want them organized. And while I'm doing this, in fact, I'll put that there. So I've got all my sklearns, all my torches in one spot, my pandas in one spot, and my sklearns in one spot. Especially if we break this into separate files later, just organizing this now will help us. So let's just grab all of this code and stick it here, right? And hopefully this should look easy because if you do it this way, it is. And we have a little error. It looks like NN, I didn't get that name right, or I missed an import. I thought it was there, but it wasn't. So no sweat. We go ahead and add it, right? But imagine if I wasn't running my code as I go, and instead of one nice little error message like this, I had like 10 of them. And I think it takes time to kind of develop this workflow, but once you do, it will help you debug and it will help you be more productive. And so now I've got let's print out the model just for fun. And I think we can print out its what is it, parameters. And I don't get details, but this tells me that the model was correctly built, right? And that's the main thing that I want to know. So now I've got the model, and now we're going to migrate over the training loop. And we'll just comment that out. Again, I have an import here, so let's just bring this all the way up top. In terms of how to organize imports and stuff, put everything that's the same together and then do it in alphabetical order. There are other ways, but the alphabetical order approach is actually really simple and consistent. That was advice I got once from a manager, a good boss of mine, about how to organize CSS. Because everyone thinks they have a different system, but if you need 9 people to do the same system, then alphabetical is pretty good. So now we've got our training loop. We're going to run it. We should see some loss information printed out. That's great. That's all I need to know. And then finally, our evaluation loop. And again, we have an import. So let's bring it up top. And let's go ahead and just copy this code and paste it in. Right. So again, nothing fancy going on here, but by doing this all in one big file, I make fixing these things really smooth in terms of my workflow. And once I have it all here and I know it all works, then we can break it up into separate files. And we might as well just let the model run just for fun, because I do want to get to the accuracy. And we see the accuracy. So I now know that I have successfully, I'm not sure what I changed there, so we're going to leave that. So I now know that I've successfully migrated all of that code out of the Jupyter Notebook into a Python file. The next step is we should break this up into a couple classes. And I do want to show you all how to actually like export and import the model itself. And then I think maybe what we'll do is I'll show how to export and import the model. And then we will do a little program design to see how we're going to design our whole student app from the command line UI to using RA model. And then we can break this up into separate files and classes and stuff and build the whole thing. How does that sound to folks? Cool. Should we take 10? Okay, let's do it. Let's take 10 minutes, and then when we come back, we'll see how to export, import the models that we've trained, and design our program. Thank you very much, folks, and I'll see you all in 10 minutes. All right, so we successfully migrated from our Jupyter Notebook to our main PY file. And Stephanie, thank you for pointing out that there's this super handy dandy export function that will export the code as well. As mentioned, I kind of prefer doing it manually because I can run the code as I go, which cuts down on the debugging workflow time. We talked a little bit about workflow in general because this kind of migration or refactoring, you do stuff like this all the time when you write code. So I think this is a really helpful set of principles to start thinking about. Let's actually import and export this code. And the good news here is that this is actually really straightforward. So let me show you all how to do it. And then we will talk about what it does. And then we will design our program. And what I'm going to do now is the quick and dirty way, because in that same principle of good, bad, I don't know, my other favorite programming saying is first make it work, then make it right, then make it fast. Fast meaning optimal, efficient, etc. So right now, and this is what I do whenever I'm kind of using something new, my job is not to make it have good design. I just want to make sure that it works straight up and down. So all we have to do is torch.save. And indeed, as this implies here, it saves an object to a file on disk. And we're going to save our whole model. But we're going to print out a dictionary. And can everyone see the font size okay here on the VS Code? Cool. PyTorch is going to give us a dictionary that for each neuron, and remember, a neuron is a tensor, which means it's this like lists of lists that have like numbers for these weight and bias values. And it's going to turn that all into some sort of dictionary that probably has other dictionaries and lists inside of it that captures that captures our whole model, everything we need to build the model that we've trained. And we're going to give it the path that we want to put it. And I'm just going to put it on, we'll just put it here on like trained model dot pth. And let me make sure I have that file extension correct. Give me 1 sec to look at my guide code here. Yeah, that should be good. I need to actually check what that file extension is, but I believe that's the one that PyTorch is going to be happy about. So now when we run this, we should have a file that is saved. So let's go ahead and test this. Right, I've written 2 lines of code. It's time to run my program. We're going to build our model. We're going to train it. It's going to take a minute because it's going to print out all this stuff. I should probably make us have less epochs just for time purposes. And now, and let me also shift to our Explorer view. Over here, we've got train model.pth. VS Code can't display it because it's in binary, which seems like what we want, or something that's not human readable or some other text encoding. And I've got my model right here. So now I'm going to do a really quick and dirty test of the model. And what I'm going to do is I'm going to literally copy all this code from main, hop over to import run trained model, paste it, and everything outside of the evaluation loop, I'm going to delete. But I'm going to leave my imports. And we're going to add import the model, right? Because first we're going to make it work, and then we'll make this well organized and nice. So there's actually two things I need to do here. I actually do need the model itself, because what we need to do is create the model like this, and then import the PTH file with weight bias settings into our model. So I actually am going to do a little bit of extra work here, because I don't want to copy and paste my whole learning model in two spots. That's a little too ugly even for me. So we're going to make a learning model file. We're going to open it up. We're going to grab all of this, and we're just going to cut it out and paste it in. And we're going to need to import torch.nn. Let me see how there's a couple different ways to do it, but just to do it the same way. Yep, that's what I thought. So I was like 99% sure about that, but it's like, if I can look at the code, why not just double check? And now we should have a model. Let's go back to main.py. And here let's have our project imports. And from learning model, import multi-classification model. And let's do this over here in main.py as well, because I hate leaving broken code. And now down here, where we build our model, we can just do model equals multi-classification model, and that should do it. Now, I suppose I could do it here. It doesn't really matter. I'm going to comment that out. And I am going to run main.py one more time, which will just overwrite our trained model.pth file. And the reason is to make sure that I've done this refactor correctly and I haven't broken anything here. And it looks like indeed there's something. It's a very simple missing import. I forgot to import the functional thingy used in ReLU. So we can just cut that, in fact, because it's not needed in the other file anymore. And put it here. And in fact, over here, I don't think we need, oh no, we still do need the neural net one. So I think that should do it. And the reason I'm running main py to train our model again is, again, I've made this refactor, and while it seems simple, it's easy to forget an import, right? And while I'm working with something new, for my mise in place, for everything set up, I don't want the bugs here to be from my refactoring. I want the bugs to be from like the new code. So let's run main py again. We'll give it a minute. We're looking good. It's doing its thing. While it's doing that, I'm going to start building out our training and testing here. We're going to do model equals multi-classification model. And then we're going to do model.load state dict for its .load learning model. I believe it was trained model.pth was the file name. Right, and I'll add it to do, like, don't hard code file
It's
name.
just train, not trained.
Oh, yep, you're right. Thank you. And in fact, oh no, it should be trained. I have two files with very similar names, which is actually not a great idea. But let's see if we go all the way down here just to double check. Yeah, we export as trained model. And that's a good point, right? This is not a great idea to have the same file name hard-coded in two separate files. But we'll deal with that once we've proved that this works. And in fact, this is an empty file from before, just when we were discussing how we might organize stuff. And so, in fact, I'm just going to delete that. I'm going to delete this. And we might recreate them or ones with very similar names in a minute, but we'll cross that bridge when we get there. And that one doesn't have any code in it either. Yeah, that's a good point, Jack. And in fact, that's like a massive gotcha just waiting to happen. So, right, I've moved my model class into its own file. As to your point, Max, we are organizing our code more. And now we've imported these weights and biases, and I've copied over the training loop. It looks like I need more data here, in fact, because I need the testing loader, and I need some other things. So at this point, I think I do want to do a little more refactoring of this code, because I want to get the testing loader and my data, but I don't want to have to like build a brand new model every time. So I think what I am going to do is grab the data pre-processing code and put it into its own file. And we might even want to put all the learning model stuff in its own directory, but we don't have to worry about that so much right now. So let's make a new file. We'll call it data pre-processing.py. And again, I'm just going to copy all of main, paste it in. For you guys, I would recommend maybe not copying the whole file because it might get easy to be lost in the sauce. But also, since we've added these nice comments showing which parts of our code do what, I know I can just delete everything from there on. If I print out testing loader just to make sure it works, we can get rid of these grayed out imports that are not being used. And now I should be able to run my data pre-processing code. And it runs successfully, which is great. So I'm not going to worry about moving this out of main right now. I don't want to get too lost in the sauce. I will add a to-do here, noting get rid of this and use the same logic that's in data pre-processing UI instead. And VS Code, in fact, like tracks to-dos. Like you can see all the to-dos in your code base somewhere. And that's true of pretty much every programming text editor. The all caps to-do is sort of an accepted comment term for stuff like this. But so now what I can do is, because every file in Python is a module, and in this one, we have all of these variables that get created, I can import these from this module into another. Like say our one to import and run the test code. So I can do from data preprocessing import, and let's see what we need for our evaluation loop, and we need the testing loader. Now there's something interesting going on here, and in fact, I had not known this about Python. When Python, when I run this code, and this is not quite a trick question, but it's borderline. When I run this code here, and it runs all these import statements, and it hits line 17, and it imports testing loader, is the Python runtime going to execute this whole module and this whole file? Because if it doesn't, testing loader won't exist, right? So anyone want to guess or know if Python will execute it or not? And this is a bit of a trick question.
I'm going to guess that it does not.
I thought the same thing. It actually does. And in fact, I had to do a little digging in sort of preparation for this lesson. And I think what I asked is, does Python execute whole module if I import something? And as the internet tells us, really as Google's Gemini AI tells us, when a module is imported into Python, the entire code within that module is executed. Now, this only happens the first time a module is imported in a given session. Basically, a session is our program is running. Subsequent imports won't re-execute the same code, but use the already loaded module from memory. So this is a great example of like that sort of next level knowledge about how a language works that's really valuable to know, and also kind of difficult to discover unless you start to write more complex things with it. But being able to talk about this in a job interview is great, right? Because that tells the interviewer that, hey, this person has written enough Python where they ran into this. I'm not sure I necessarily agree with this design decision of the Python language. But I think, while this explanation isn't great, the reason they did it is because since we can import any top level variable or class or function from a module, I guess the logic is Python needs to run the whole module to do any setup, which does sort of make sense. And I just want to pause and check in and see if folks have any questions about this or anything that we've been doing thus far. And how are we feeling, by the way? Okay, awesome. I'll take that as at least a 0.5 if we're measuring between 0 and 1. So
Yeah, I guess I have to say, like, I'm kind of feeling a little lost now. I guess when it comes to following along, I think I'm just gonna have to rewatch this portion of the video once it's up.
got it. Okay, no, I'm glad you let me know that because I can move fast sometimes without realizing it, or jump around a bit much. Are other people feeling maybe a bit lost as well, or how are we doing?
I mean,
Okay,
I understand like the steps, but implementing it myself, I think would be a struggle for sure.
right, right. Um, Really, what I want y'all to take away from this is not like every single literal step. Like, I copied the whole file in here and then deleted all the other stuff. What I want y'all to take away from this is this idea of this workflow, and start thinking about, like, when I have to do this, how can I break it into smaller pieces that are simpler? And what can I do later? Because it's when we try to eat the whole meal all at once. You know what I mean? Like, think about, it's different for everyone, but my guess is if we had gone straight from taking the Jupyter notebook to making a bunch of different files and putting things in, for me at least, that would have been harder to debug. If that's actually easier for you to debug that way, then more power to you. Absolutely do it that way. But that's the main thing I want to show here is like, when you have something, think about how can I break it into smaller steps that are simpler, and like what are my knowns and unknowns, and what do I need to focus on just to make it work. And to kind of go back to the other part of the diagram, try to think about separating like design versus building, right? Because what we're doing now is not really we're not really designing the program that we're going to build. But if we're building a skyscraper, you got to go to the construction site, you got to knock down the other stuff, you got to have the big earth pounding machines come in and pound the ground, and you might have to build a really huge hole in the ground and pour some concrete in there or something before you can even start building the skyscraper, right? And I just want you all to start thinking about like writing your code as a process, which I realize is a little vague, but will really help. And so the process that I'm showing y'all is do it in small chunks and run the code as you go. And make a list. I usually, when I'm doing this, I'll actually have a list on a piece of paper or in a to-do comment or in a comment block somewhere. Because I realize there's a lot of steps, but I just want to reiterate, we've only added one bit of new code here. And that is this save command right here. And then we've added this load command right here. Right? Everything else is just moving around the code we already wrote. So there's a lot of different ways to skin the cat. There's a lot of different ways to get there. The main thing here is I want to show you all how, if you find a good way to do it piece by piece, you make your life easier. On that note, let's run this thing and see how we do. Now that I've built the model and I've loaded this saved dictionary, and let me do a quick sanity check to make sure I'm not missing any steps. I think we
I
should
also
be
have a
good.
quick question.
Yeah.
On line 47 there, the torch.save, can you go over that one more time, please?
Yeah, absolutely. So let's see here. And we are in main.py. And in fact, I don't want torch.save there. So main.py is where we put our whole Jupyter notebook, right? It has data pre-processing. It doesn't show me the comments, which is a shame. But it has data pre-processing, it has model training, and then we have evaluation. So we've created our model, right? We've already done the data pre-processing. We don't need to look over that. We run the training loop, exact same code we had in our Jupyter Notebook cell. Once the training loop is done, we're going to see how accurate it is because it's nice to print it out and see it. But the model is already trained. And that is what has tweaked all of these weights and biases. If we go way back to one of our diagrams here. And in fact, let's just go to this one because it's got, it's a bit cleaner. It's a bit simpler. Right? We've been talking all this stuff about neurons. And at the end of the day, each neuron has some sort of weight and some sort of bias value that's stored in a tensor. And every single neuron has this. And in our training loop, we're tweaking these weights and biases with backpropagation. And what PyTorch does for us with tensors is it remembers all these values. So it knows these values for every single neuron and all of our layers. And so then what this save operation does and this dot state dict operation does is we get all of those settings of weights and biases for our whole model exported essentially as a dictionary. And then we save it to a file. And in fact, if we hop over and we look at some of the PyTorch commands here, so torch.save saves an object to disk. That one's not that fancy. If we're looking at saving and loading models, as it says here, we're using this to save the model and all of its tensors and all of those things. We haven't really talked about what is a state dict, and I don't want to get too lost in the sauce, but as it says here, this is a Python dictionary that maps each layer to a tensor. And I don't want to, frankly, I would get a little lost in the sauce with what they're saying here, and we could play around with it and we could, print stuff out and look at it. But this is really the main thing, that in a bunch of dictionaries and lists, the state dict has all of the weights and biases for all of the neurons in all of our layers. Yeah, great question, Chase. Does that help answer your question?
Yeah, it does. So basically, like when you train the model, that information's saved there, and then the next time you run the model, it pulls that information back up.
Yeah, exactly. And this was always there under the hood. PyTorch, saves it for us. Like with each epoch, the way the model gets better is it has all the previous weights and biases and it tweaks them. Right? But now we're spitting that all out into a file. And it's sort of like, this isn't the best metaphor, but if the model class is maybe like the factory for building a car, all of these weights and biases are telling it like which model car, is it the model that has the diesel engine or the gas engine? Does it have the leather seats or not? Does it have a sunroof or not? Like all of the features, not in the sense of like features like inputs like pH, but all of the different parts that make up our model. Yeah, great question. And do other folks have questions around this as well, and what this save operation is doing? Because that's actually a really good one to touch on. Okay, cool. And I think I would recommend just reading the PyTorch docs on this. You can just skim the parts you don't understand. That's totally fine. Most of my CS undergrad was reading documentation that I only half understood. And in hindsight, it was probably one of the best things about it, because reading documentation is an art. You have to learn what to skim. People talk about stuff in a really jargony way. So it's important to start reading docs to build up that practice, to develop that skill. Because there's good stuff in there. As it says in here, when saving a model for inference, and inference is when we actually feed data into the model to get an output, like we do here, or like we do for training, or like we're going to do when we write our command line program. We really only need the parameters that the model learned, the weights and biases that it tweaked. Right? So to go back to our diagram, it's like the model class gives us all of this, right? It tells us how many layers we have. It tells us how many neurons are in each layer. The state dict, the state dictionary that's there under the hood is what's keeping track of the weights and biases in each neuron for in each layer. And when we do that save command, it exports those weights and biases into a file. And so if I want to recreate my trained model, first I need the blueprint. I need an instance of my class. But all of these neurons, they have their like initialized random values, but we have these nice tweaked, tuned, trained weights and biases values here that we can just import and feed in the right spot? Yeah, great question. And folks, does that help break down sort of what's going on there with that save and import step?
One more clarification question on that.
Yep,
So in the path that the file you're saving to, if that path like does not exist, does it just create a file for that?
that's exactly what it does. Yes. Yeah, good question. It'll just make a file. Torch.save does the work of saving it to the file system. We could, in fact, I guess, use this to save like individual tensors, which if we're getting fancier with other things, maybe we would want to do. But yep, it'll just make a file with that name. I'm not sure what the PTH file extension is for, but it seems to be the one that it wants. All right, let's run this sucker and see how we do. So let's go to import run. And remember, this is the same evaluation code we've been working with all week. I've just copied it and pasted it because I just want to test that I correctly build the blueprint and load in the weights and biases into the blueprint from the file. I want to make sure it works. I'm going to make sure it works by just putting it through the evaluation loop. So that's the purpose of the evaluation loop here. It's not for anything about figuring out how good our model is. This is just the quickest, laziest way to make sure that my load is working. Does that make sense? Awesome. And let's run this and see how we do. And look at that. We got something. I don't care how accurate it is. I don't care about any of that. All I care is that I successfully built a model, loaded this information, it loaded it in successfully, and it spat out an accuracy number. And, you know, if I wanted to, I could dig a bit deeper, but that basically gives me enough confidence that this is working. And that was really my goal here. So we've now seen how to save and export a learning model that we've trained, right? And PyTorch gives us this one command that we can use to do it, which makes it very, very simple and very friendly. We give it the file name that we wanted to export to, and then we've successfully imported it. And what we do is we build a new model that has not been trained at all, and then we load these nice weights and biases that are tweaked and tuned from all the training into it. And the evaluation loop is here to test that our model, import has been successful. Okay. How are we doing? Do we want to keep rolling or take a break?
If we can take a break.
Yeah, I think we've been going for probably close to an hour. All right, let me pause the recording real quick. All right, so we've gotten our model working and saving and exporting working. We've taken care of first make it work. Now we're going to make it right, but we're adding more features. So let me walk through what's going on here and explain the important things. We'll learn the term user stories later, but in essence, you can think of a story as like, what is a feature from a user's perspective, like not a programmer's perspective or anything else. And so as a user, I want to be able to input student information. For now, we're just going to have it be where I will just manually input like one row of data with parental education, weekly study time, tutoring, parental support, all that good stuff, all of our features. This is not really a proper user story because I'm telling it how it happens. But as a user, I then want to see what the predicted grade that a student will get in the class, in A classes. And I want it printed on the command line. And so the learning model is going to take that input and it's going to return a prediction. Now, I've made some very careful decisions about having some features be out of scope. And this ties into this concept of a minimum viable product. Has anyone heard this term before? I see a couple nods, a couple shakes. It's from the startup world, it's from this idea of the lean startup. You'll hear MVP. It's been around for ages. And again, like a company has like 100 grand, and if we don't launch something that gets enough users with that money and 12 to 18 months, then the company dies. So we have to really trim the fat, right? So things that are important, like say validating input from the user to make sure it's correct, air handling, things that might be really valuable but aren't absolutely necessary, like saving the student information into a dictionary, like you all saw for the OOP review, are going to be out of scope for a minimum viable product. And this is the most important thing you can do when you're working on assessments, working on coding assignments, and just programming generally. Like, be ruthless about what is absolutely necessary, what's your minimum, and what's not. Because if this always takes longer than you think, right? But if you do this first, you get what you need, and it gives you the information to help go and do that. We won't always teach this way. For teaching and learning purposes, we sometimes kind of like eat the whole meal. And if you find it easier to do it all, that's not the end of the world. This is kind of a tricky workflow to learn, but it is important to think about, especially for personal projects. So let's talk specifications. We're going to make 2 classes basically, and I think we can get away with pretty much everything that our program needs to do with these 2 classes. So I've done this for, a bunch of years, but this process that I'm about to go through now should take you, it could take you an hour and it would still be time well spent. We're going to have a terminal UI class that deals with printing things out to the command line, getting stuff to the command line, everything from the command line. And we're going to have a model handler class that deals with everything related to the learning model. I could probably come up with a better name for it, but handler is sort of the lazy programmer name for something that does a bunch of stuff for something else, like a wrapper. So our terminal UI is going to probably need something like def, get, you know, prompt user for data, that to get the student data. And then we're probably going to need some sort of like def print student grade. And we might need more, but we'll worry about that later. Our model handler has to do a whole bunch of stuff because we need to do data pre-processing. And my assumption here is we want to train a model, save it, and then use our saved model. So those are the features that we're building in here. So this is maybe a bit beyond MVP, and that's for learning purposes. Build the model, train the model, evaluate the model, save the model, load the model, and run a model, a trained model. And I'm going to use the term trained model very specifically here. Run a trained model, feed user input into a trained model. So I'm going to need to do a number of things to accomplish this. I'm going to start with the terminal UI because it's simpler and because it's visual and interactive, so I can get code printed out to the screen very quickly. And I'm also going to, all this code in main.py needs to go away because I want main to be where I do my work. I think what I'll do is I'll just make a file named runner.py so I don't have to mess around with names. And let's open up runner.py. And what I'm going to do here is I'm going to keep a split where I keep runner.py on the left and whatever I'm working on the right. So let's put terminal there. We'll have runner there. We'll get rid of that, and we'll get rid of that. So I'm going to keep this all pretty simple. I don't even know if it's going to do anything in the under init method. We'll just call it prompt user. Input, and I do want to open up my CSV file here because I need to see all these fields. So I need age, and we're going to cast this to a string, and we're just going to say age. And I think it should look like that. Gender, same thing. As I said, this is a minimum viable prototype, so this is going to be ugly. I'm not even going to make, I will add some nice prompts because it will help me debug. So I think, I don't know if 0 is male or female, but we'll say, and now we've got gender. Ethnicity. And if we look at how they represent ethnicity in column 1, 2, so we've got now gender and now ethnicity. It also appears to be some sort of number coding system of integers. So we'll just say like an integer between 0 and 5, just as like guess int 0 to 5. We'll make it 0 to 4 or 0 to 3 just to be conservative. Because again, this is an MVP. I don't need it to have complete correctness right now. And let me make sure I have my parentheses right. I need one more. And after ethnicity comes parental education. And again, there's undoubtedly a better way to write this, but this is simple and fast and relatively foolproof. Study time weekly. Absences. And after absences, we have tutoring. Again, there's definitely a better way to do this, but this is quick and dirty. Parental support. We're almost done here. We have extracurricular sports, music, volunteering, and GPA.
I just have a quick clarification question.
Yeah.
So basically, like what the prompt is doing is asking for all this information from user input, and then it's going to compare all the user input information to the model that's already like predicted a likelihood of your grade, right?
Yeah, that's correct. Like
Okay.
it's the same, exactly what we do with the model in evaluation mode. We just don't have a correct answer to evaluate against because, the goal is the model is well trained enough at this point that we could feed new data into it and get a good answer, a good prediction.
All right. Thank you.
Yeah, great question. Does that help answer your question, Chase?
Yeah, it does.
Awesome. Yeah, very good question. That's very much what we're doing here, right? Our model is trained. We're going to feed data into it. And this is extracurricular. and the model should give us something good. And now I think we have everything that we need. Not gonna lie, this is a pain to have 13 variables. In hindsight, some sort of like dictionary or something would have been nicer, but that's okay. Um,
You have absences twice.
Say that again, James.
You have absences twice, 11 and 12, line 11 and 12.
Oh, thank you. Absences must be meant to be something, tutoring. And as I'm looking at this,
Now you have tutoring twice.
okay, I think we're close enough. Um, and let's just make a list named data, age, gender.
I was just gonna say, looking over the CSV file, like we don't even know like what the numbers even mean. Like when it comes to ethnicity, when when it goes 0 through 3, like what would 0 equal? What would 1 equal? Like
Well,
you would know.
what's your best guess as to what they might? We don't know exactly
I,
what they
I mean,
are.
I mean, different ethnicities. I know they're
Yeah,
probably different, but just looking at the table, you don't know.
I
no,
would think
we.
like I would think that like one means like one specific ethnicity
What,
or
Max?
something. I'm not sure.
I couldn't hear you.
I said I would think that one or two or three is representative of like a data set. Like one equals Asian, another one equals
Yeah, yeah.
Yeah,
I
other
understand. I understand the
specific.
concept of that, but just by looking at it, you still would know.
But
Like,
yeah, my question
yeah.
is following: how does the program know what these three?
the short answer is we don't care
Oh, sure.
because, especially for testing and building this, as programmers, if we were doing this for real, we absolutely would care. And if we didn't have that, we'd have to go talk to maybe a cross-functional peer on a different team or someone to get that information. But right now, all we care about is feeding data into our model and then the model making a good prediction. But you're absolutely right. And I think we should add that to it'd be better to have that contextual information for the data, but we don't actually need it. Um, so I've got this prompt user here. It's coded up. It took longer than I thought, unfortunately. And I think what we'll do is we'll do like self data equals just an empty list. I will do it like that. I'm probably going to fake this in just a minute in the interest of time because I'm realizing if I have to type this in all the
And
time,
and
it's
and
going to
some of
take
these are
forever.
also floats too, in the CSV table.
Oh, that's a great point. That's a very, very good point. We do have to deal. Let's convert these all to floats because I think PyTorch will handle the float to int. And if it doesn't, what we'll just do is when we hit the error, we'll tweak where it needs to be tweaked. But that is an excellent point. That is a really good point. Thank you, Jason. So we've got this data. We've got this stuff working. I could run this to print this out. It's honestly going to take forever if I do. And I would do here self data equals data. So let's in fact now write def fake prompt user input. And what I'm going to do is I'm going to grab this and I'm going to just paste this whole thing right there. And this is sort of me being expedient in the interest of time. And what I'm going to do is I'm going to hop over here. And go. Stick this all in the list. We're going to do some list destructuring. If I might need a little internet help reminding me how to do this. Python list destructure. I think I can just do it like this. Age, gender, ethnicity, parental education, study time, weekly. I mean, to be honest, actually, what we can just do is that. So that's like the really lazy way to take some data here. I'm just going to trust that I got the order of this, that I didn't goof, and that I have this the same as the data. But so now we can fake some user input. And now I have some data. And so now I think what I want to do here in my runner PY is from, and I should have named this file differently. I apologize. I was thinking JavaScript, not Python. The file name should be all lowercase terminal underscore UI.
Hey, Adam, I know you're going fast, but you need to get rid of the student ID in your number down there.
Oh, thank you so much. Very good call. Yeah, that is the danger of going fast. Thank you, James. Very good call. So let's see. Let's UI. Let's just print this data. Make sure that that works. Great. Let's just, I'm not even going to run through all this. I just want to make sure that that works. And we can get rid of those. So I now have a terminal UI class. But now what I need to do is once I get this data, we need to call the model, right? So what we're going to have to do here is really prompt users going to have to drive the bus for us. And I think I'm going to make a class and we're going to call it get and return prediction. Ask self.data to our model, get the prediction, print it out. And so for the moment, we're just going to print out prediction is, and we'll just say prediction equals none. Right? And I built myself a little skeleton here. But now what I can do is right here, I can do self get and return prediction. And I would want to do it right here as well for the real function. And now if I run my code, we get a prediction that is absolutely useless. And this is sort of TDD style. But now what we're going to do is we're going to make our model handler class and use it in here. So I will name this one the right way. And let's load it up over here. And before I start building this, I just want to check in because I did kind of speed up there. So I want to see how folks are doing. If there's parts of this that's good for me to go over, if people are tracking and what questions folks have.
I think once the demos and notes gets pushed, it'll be pretty useful to have how you did this, and then also looking at the notes because the video will be up too.
Yeah, totally. And so just to recap, because there was a lot of moving around in here, we've got these two classes. I added a test class in here, but that for sort of faking purposes, but we can sort of ignore that in our design. But I've also added this class has really become get and return prediction, right? And the data equals we grab the data, we assign it to the model. I'll do just def init. That's where the student data is going to live. And let me give myself a little more room here. And we get it and we put it here. And what, in fact, I'm going to do here is something like this. Self.model handler equals model handler. And over here, I'm running out of room here. And does it help to see it laid out this way a bit? Or not really?
It helps me. I'm a visual
Okay,
learner, so it definitely helps.
awesome. Thank you. And we have to build the model handler, but in essence, we're going to have some sort of method named like def, get prediction. And it's going to do something like this. And what we haven't done, and let me kind of copy this because I think there's really two things going on here. And we'll just make this sort of orange. We'll make it green. And we'll make all of this green as well. Right? I wrote out a lot of the stuff that we want the model handler class to do. And the way that we're going to do it, in essence, is in init, we'll do self, we'll call it maybe like trained model, or we'll just call it like model. We'll worry about the model file later. But in here, we're going to, make, train, etc. the model. I'll write some helper functions along the way, but our model handler will have a trained model on it, right? So then this guy over here, its job, following the single responsibility principle of OOP, is just to get the user input and pass it on to this other class, the model handler. The model handler will actually make the model, it will actually feed it in and then print it back out. And I do apologize, we're a little tight on time. Are folks okay if we go maybe 10 minutes over? Okay, awesome. So let's build this model handler. And do folks have any questions before I dive in? Okay, cool.
I do have one quick question. Well,
Yes.
it might not be quick. But I had a question about the little function called if name equals main. Is that something we would use here? And then
Max, I'm sorry, it's really hard for me to hear you.
I'm sorry,
Uh,
can you hear me now?
yeah.
I was curious, if we would be using, if name equals main, would that be used here at any point?
We could, but it's out of scope for a minimum viable
Gotcha.
product. I'm not going to worry about it right now.
Curious.
Yeah, we totally could, but we don't need to, so I'm not going to worry about it. Right? That definitely falls under the future features category. But you're absolutely right that that is a good technique. Let me go ahead and let's start building our model handler. And I think over here, let's have the terminal UI open so we can see the two together as we go. So I need a dunder init method. It's going to take in self. And we need to do a whole lot of things, right? We need to build a model. We need to train a model. In fact, I'm just going to make a whole bunch of methods here that are going to be like skeleton placeholders. So, and we also need to pre-process data. And just for sanity's sake, I'll put that up there. We need to train our model. We need to evaluate our model. And we need to be able to save our model and load our model. So how do we do this? We are going to systematically, one piece at a time, move in everything from main PY and our other files. Now, normally, as you saw me doing in this demo, like after creating each of these, I would actually run the code. In the interests of time, I will probably skip that step for the most part. So I know I'm going to need to import pretty much all the things related to PyTorch and models. So let's just do that here. I also know I'm going to need to import our multi-classification model class that we already made. And just as a friendly reminder, that is this bad boy right here. I should probably rename this to be multi-classification model, but that's okay. So I've got this whole class here. And we will indeed use that to build our model. And in fact, we can do that right here. We can do self.model equals none. And over here in build model, we can do self.model equals multi-classification model. And so we'll worry about when we call this later. I just want to build out these pieces right now so we can see them. So pre-processing data is pretty straightforward as we've moved all of that code elsewhere already. So I am in fact going to just copy all of this. And really, it should be its own class. This is going to be a pretty big, messy method. But that's okay, especially, again, for an MVP. So now, as I go through this, I am going to get rid of stuff that we don't need. We can do nice things like this. In fact, I'm not even going to worry about that right now. I'm just going to put a to-do, move into constructor. Just getting rid of code that's going to make it confusing to read the code. Get rid of those print statements. Get rid of those print statements. get rid of that print statement. So we've got all this stuff. Let's assign it to attributes on our class. And I'll add them up here in the constructor. So that other programmers understand the intent of our code. And I believe that's all we need for, let me check our other code to see if we need other things from the data preprocessing stage. So let's hop over to main PY and let's take a look at our training loop. Right, and so here we need the training loader, but that's really it. And let's go ahead and just copy all this stuff here. And let's put it in right here. And we'll get rid of that pass. I do have to do a little fixing of indentation. Otherwise, Python will be extremely unhappy. And over here, wherever we see model, that's self.model. So I'm just going to do this because that's a quick and easy way to solve that problem without having to deal with modifying many lines of code and possibly making a typo. I'm going to do it the same way over here. Right? And we can always refactor this later to be nicer looking, but that's one nice trick for refactoring code. It would be nice to make, make this a param passed into build model, but I'm not even going to worry about that right now. So now we've got a build model function using everything that we've done. And we can, in fact, do the same thing with our evaluation of the model. Where, again, the real trick of this is being careful in, if you're going to copy and paste code, being careful and systematic, because that's when errors happen. And we can get rid of pass down there. And I'm going to do the same trick here of model equals self.model and testing loader equals self.testing loader. And now we've got our evaluate, right? So what we might want to do is maybe even in the constructor, we would do self.build, self.train, self.evaluate to build a model. And maybe, in fact, we want to do should build, train, should, let's just call it train new model. And we'll set it to false by default. And we'll say if train new model, then we do those things. And now we have a lot of control over if our model handler will train a new model or not. I could even put these in a train new model method as well. It's really sort of dealer's choice. And then the last piece here is saving the model, right? And again, the nice thing here is this is really just one line of code. Oops, sorry. And here there's just the one model, so I'll just do self.model. And here, what I am going to do is change this file path. I am going to go up here and I'm just going to hard code this. And I'm going to say self save model file equals, what was it? Trained model dot PPH, to do, make better, right? We should take this as an argument or set it somehow, but that's a quick and dirty way to not have that be hard coded. And so now down here, I can have this be an F string to self.save model file. And the nice thing about that is over here then in the load model, where again, if we go to the code that we wrote here, that imports our model. And again, I'm just going to copy and paste it in. And we do well, we'll deal with the model in a moment. But we do load state dict. And here now we can do, and in fact, I don't even need an F string here because this is a string. So that can just be like that. And we can do self.save model file. And now I don't have that hard coded. And so now I do have to decide here about creating a new instance of the model or not. And I think we do want to, right? Because this is really what we want to do here. We want to create, like, load a pre-trained model and have it be ready to use. So I really think what we want to do here is we want to self build model, builds untrained empty model. And now I can do self.model.load. And now that untrained empty model now has all the nice stuff. And I just need a closing parentheses and that line of code should be correct. So as an example of using this, let's open up the runner. And let me just comment this out. And let's go ahead and import from model handler, model handler. And it looks like maybe I have that file name wrong. I just forgot the import word because I've been typing too long. So let's, we can try this out, right? Let's do just MH for model handler. And just for fun, let's do all the steps, right? Let's do MH build. We have to do MH. We have to remember to pre-process our data. So again, these methods are tools, and you could write a helper method here to combine them all, or as I've done here. And in fact, we definitely need to do the pre-processing data here. So it definitely makes sense to put all of these in a method. And in fact, let's do that. Train. Let's just call it train new model. And let's put all of these here. So I can use it however I want. And in fact, we can just call it right here if we want. And now we have a lot of control, right? When I instantiate this, that will in fact train the new model, and we should see a whole bunch of stuff printed out. And we may get some errors because, as I said, I did a whole lot of moving code around here without doing anything. But just to walk through what's happening right now, we've called the dunder init method on model handler. We've set train new model to true. So it calls this train new model method. That calls the pre-processed data method that does all our stuff. That puts the training loader and the testing loader data as instance attributes on our object, our model handler object. We build the model, we train it, we evaluate it, voila, job done. But we want to be able to save and reload it. So let's delete this trained model file And once this is done, let's go ahead and save our model. Let's prove this works. We should run it, and we should see a trained model file when we run this code. And we'll give it a minute, and it'll do its thing. And while it's doing this, let me pause and check in and see what questions folks have, because I know I moved through a whole bunch of stuff there at a relatively quick pace. Was it helpful to kind of see that workflow for building something? And did you all feel like you were able to kind of, not necessarily all the details, because that's not the point, but sort of see the steps of the workflow of how I go about writing code and building stuff?
Yeah, I think it's crazy how you're able to code so much and it just happened to work.
Well, yeah. Well, first off, I've been using this text editor Vim that lets me like grab whole lines and paste them around, which you can do with VS Code, by the way. Like, we want y'all typing to get comfortable with it, but you can. There's a lot of keyboard shortcuts to do it. The secret was what we just spent the last 2 hours doing, right? Because I knew that all this code worked because we ran it, and I had everything for training here, and I had just the data preprocessing code here, and I knew that it worked because we ran it. And same with all these other steps. And so there's absolutely a lot of like experience that goes into this. But to go back to that chef term of mise en place, like if you kind of start setting stuff up piece by piece from the get-go, then it kind of snowballs. You know what I mean? Like, if we hadn't done the last 2 hours of all of that, there's no way I could have done all this, because I had here my code already organized the way it needed to be, and we knew it was in a good state because we had run it. But absolutely, yeah, a lot of this comes with time and practice. We've got our model running. And what other questions do folks have too? Because I do want to check in with people to see if there's things that might be good to dig into or show again.
I think it's very similar to like the video store class for the assignment we had. I think like I don't really have any questions. It was just like this would probably be like a good weekend project for us to try to figure out, even if it's not graded. Just because I
Yeah.
think what you just did in 20 minutes would take me 2 days probably. But I don't think any of it's like
Yeah.
new that we haven't learned. So I think it's pretty understandable big picture wise.
Yeah. That totally makes sense. Yeah. And this is a good assignment for this afternoon. And I think you're right. You guys probably won't get it done this afternoon, but we don't have an assessment coming up on Friday. So it would be a great thing to do over the weekend, is to migrate your Jupyter notebooks over like this. And let me just take it home by sort of showing the final step here. And you're totally right, Chase, too. Like, the layout is similar to the video store class, and that's not, that's by design. It's these sort of object-oriented principles of the single responsibility principle is my favorite. Like one class that does one job, and you use the classes working together to get stuff done. So let me show you all how we can use this now. So we have trained a model, right? And in fact, we've saved it. And we definitely want to save the changes to model handler. So in our terminal user interface, we prompt the user for all this stuff, blah, 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 blah. But we need, when we create the terminal user interface, we need to get a model, right? We need, I'm just going to call it a model just for simplicity of names. And so let's open up our runner and talk about how to do this. So first off, we should probably put this here. I'm going to comment this out. I'm going to say, do this to train model and save to file. Let's assume a trained model has been saved to file. And in fact, I think the better way to do it is we're always going to need a model handler class, but mh dot train new model mh dot save model, right? And this is why it's nice having methods for flexibility. Let's assume we have a saved model. We can do model equals mh dot load model. And then when I create the terminal UI, I can just pass in the model as an argument. There's other ways to do this. You could use some sort of method instead of passing it into the constructor, which in terms of design might actually make more sense because I don't want my terminal UI to have to be dependent on a model existing. So in fact, we can put this up here. Let's just name this like lowercase UI. Let's add a nice little method here. Let's call it import model. And that is literally all it's going to do. But what this means is now I can do UI.import model model. And my code is much more flexible, right? I don't need to pass the model in the dunder init method for my terminal UI, which makes sense. And now over here, where we get and return input, this skeleton code that we wrote way back when, I can do prediction equals self.model self.data, because the data is this one row of stuff. So fingers crossed, if we run this, we will have loaded up the model we already trained from a file, attached it to our terminal UI class, fed it some fake data because I'm lazy and I don't want to have to manually enter 13 things. Though we can because we're using the same method in both spots, and then we get back a prediction. So this is very much our moment of truth. And let's give it a minute. And unfortunately, we did get an error. I think I just forgot to modify my dunder init method, right? The error message said dunder init for terminal UI requires one positional argument model. This is the danger of refactoring. I refactored this to not pass the model in here, but I forgot to make a change. And we have some other errors. None type is not callable. Prediction self model, self data. So it looks like the model may not be what we want it to be. I realize we've also gone pretty long, so we should probably wrap up. And indeed, it looks like, oh, I know exactly what the issue is. This is an error of judgment on my part. Load model does not return anything. It just loads the model into the model handler. So really, the way to do this is we pass in the model handler. I'm going to rename this to attach model handler. I'm going to rename this to the same thing, attach model handler. And we're going to self.mh equals none. And this is, I do apologize because this is definitely me having sort of Zoom brain here, as I'm sure we all have, but we're so close and I would love to get this working. So we've attached our model handler. And in fact, I think what we need to do here is add one final method. We have build, train, we have evaluate, we have save, but let's have def get prediction, where we just pass in one row of data. and we return self.model, we return the output from that. And then over here in our terminal UI, this get and return prediction does self.model handler dot get prediction self.data. Now, I'm changing a whole lot of code at once here. So, this is where the rubber hits the road. And Jason, unfortunately, it turns out we did indeed have errors. We just didn't know they existed yet. And so I'm not going to try and debug this on the fly. I will debug it before pushing the code up. Argument input must be tensor, not list. Yeah, so the issue here, and this is actually a very good point. The issue here is we have to convert a row of user input into the right shape tensor for our model. So we need to make a model handler method to do this. So that is absolutely a step I forgot. And does that make sense to folks, the issue that we're running into here with this argument must be tensor, not list, and why it's happening? Yeah. And just to reiterate, if we hop over to our terminal UI and we look at our fake data, and let me close out this. If we look at our fake data over here, I just grabbed the first row from the CSV file. But remember that the model needs stuff to be tensors. We do all this data pre-processing to take those lists and turn it into a tensor. And that tensor is actually what gets fed into the model when we evaluate it. And indeed, I may even need to add the data loader code. I probably don't need batch sizing and stuff. But I need some transformation, probably just into a tensor, like we do here, to get this to work. Something like these lines of code. So that's what I forgot. So that the goal is to take some user input, right, and feed the user input in here and have the model that we've trained, whether we imported the saved file or just trained it now, look at this data and actually give us an output. And just to recap, because I know it's time to wrap, again, the big picture for today is we saw how to import and export model files, right? Which is shockingly easy. It's just 2 lines of code. And we've really spent a lot of time really with software engineering, with migrating the code outside of Jupyter Notebook, right? And then actually a whole lot of software development that's not really about AI at all. But hopefully you all can kind of see how, whether it's a model that like we build or that someone else uses, like we can actually use it in our code like this, which is really cool. And how it's important to understand how the model works, because, even if we're using, Facebook's Llama open source trained model, well, they have a really nice API, but at some point I might need to turn some lists of data into tensors, right? And that's really been the goal of this week, is to give you all those tools so that when you're working with learning models, whether it's one that you made or a third-party one, it's not a black box. All right. Thank you folks so much for sticking around. I thought this was going to be a short lesson. It was a long one, but hopefully a good one. Why don't we break for lunch? Because I've definitely run long, but I'm happy to stick around for a little bit to answer questions or dig into stuff that folks have. So thank you all very